Hey Jimmy,
How are you?
I'm good, I'm good.
Hello?
I'm good, Jimmy. Now, actually better than
Oh, I
yesterday.
saw I saw an email. Oh, okay, because I saw an email from you that was saying we couldn't have class yesterday or
Right,
something like that.
right. Okay. So, uh, okay, now I'll be muting you, Jimmy, and because others are joining. Okay. Hey Ajay, good morning. And I think other people, at least two more people will join just now, and then we can jump start. Okay, okay. Now you can hear. I'm sorry, I kept it muted. Oh, that. Okay, okay. So here we are. And so what exactly is Scoop? Okay, yeah. So Scoop is a tool. So today we are going to talk about multiple tools. First one is Scoop. Scoop is Scoop basically helps you extract data from a structured data store into Hadoop for further processing. And when we say Hadoop, it means three things. First one, HDFS. Second, Hive. Third one is your HBase. Okay. Now I'll go through example of various imports and then we'll move on. All right. Now also you can move back data from database to HBase as well as from HBase to database. Okay. So it works both the way. All right. And now since there could be lot of databases, right, from which you might have to pull the data into Hadoop. When I say Hadoop, again it's HDFS, HBase, and Hive, and maybe Accumulo. There is a component called Accumulo. Okay. Now, so to support all sorts of databases, it provides a mechanism of connectors. Okay, similar to the JDBC driver. And you can, in general, you can use the JDBC driver to connect most of the databases. Alright. And it's a completely open source tool. For this example, we will be basically taking uh, using the Hadoop server 2, hadoop2.nobigdata.com. Can you see the screen? Okay, okay. So now I'm connected to hadoop2.nobigdata.com, and over there, if I say scoop, so it says that, so these are the various commands, and out of it, import and export are the primary ones, right? And furthermore, you can, go ahead and check out what is the syntax of import looks like, all right? In detail, it goes through the detail. And Scoop connector is a modular component that uses extension framework to enable Scoop imports and exports for a data store. The whole mechanism is like a JDBC driver, and so that people can develop various new connectors. Okay, so although there are native connectors for MySQL, although there are native connectors for MySQL, PostgreSQL, and PostgreSQL and Oracle SQL Server, Microsoft SQL Server meaning, and DB2. And there is a generic JDBC connector which connects over JDBC. Okay, so which effectively means any database that supports JDBC is also supported onto Flume, onto Scoop. And there are other third-party connectors also like Neteja and Teradata for transporting the data. Okay. Now let me just go through couple of examples. So I have already started my SQL. In case you are doing it on local machine, you can use this command as root to start your MySQL if it is not started. Okay, and let me just see if so I'm logging to MySQL as root, and let me see if I have show databases. So this is MySQL console, all right, it shows me these databases which are there. So this scoop example is move scoop example to script. How do you in SQL, how do you rename? Okay, so we'll just do most of it using a new database, a scoop 2. So we create, first of all, we're creating some data into MySQL, and then we'll import it into our scoop, into our HDFS using scoop. All right. So I've just granted permission. Sorry. So the command should look a bit like this. And instead of creating, I've just need, because it's already there, right? And so we have created a table in MySQL with these columns: ID, widget name, price, design date, version, and design comments. Okay. Take a note that price has got a decimal data format, while design has got a date format, and so on. Right. Now we are going to insert some values into widgets table. Okay. And now let's see. Select star from widgets. Is it added? Yes, it is added very well. Okay. So we have added into MySQL, and now as a next step, we are going to import it into HDFS. Okay. So we can say Hadoop ex2 and table is widgets. Alright. Now let's see if anything happens. Not this. Now we have to exit from MySQL because we have created our table. And now we are saying Hadoop import. Now our connection URL to MySQL is this. It says that MySQL is running on localhost and this is the database name and this is the table which we are trying to import. Okay. And minus M is basically how many reducers do you want. Okay. Okay. Now let's see. Okay, what does it say? Access denied for the user this. Mhm. I think we gave permissions, right? I think we gave permissions to all the users. MySQL, my so basically there's a permission problems. And this is fine, right? So I say use scoop ex2 and then select star from widgets. And yeah, select star from widgets. It is fine. And let me just try to execute it again. So it says that this is okay, which keeps on error executing the statement. Access denied for the user localhost to the database. Oh, I got it. So basically, it's a scoop X, not Hadoop X, and that is where I were messing up. So the name of the database is this. Okay, okay. It should not be asking you a password, Iraya. And let me see, what does it say? IO exception running import cannot delete user student staging. Name node is in safe mode. Okay, okay, okay. So it says that name node is in safe mode. Actually, the guys who are doing the project, they are on the same machine and they are importing a lot of data these days. And that is why it is happening. So I'll just ask. Probably I will have to separate out the project guys from the classes. I was thinking that I could pull in, but or what I can do is basically increase the further. Okay, okay, So let's see if something frees up. Till then, we'll discuss rest of the things. A- And the other one is that, so this will basically create a file into Hadoop with this name, which we can see at later point of time. And also it will create a Java file, which will basically be used for the imports. If you want to repeat the same process, you can compile widgets or Java, and then you can use that one for repeated imports. Because when you import something from a SQL database to HDFS, it involves a process of conversion into from a conversion as in delimiting text with a certain uh, delimiter. Okay. So by default, it is Control A in case of scoop, I think, and then I think it's Control A. Yeah, I think Control A is the default delimiter, and all right. So the next the next use, this is just basically translating a widgets file into a local file in HDFS, right? The next stage is to take a table from MySQL database, take a table from MySQL database, and then move it to the Hive. Now, when you move it to the Hive from MySQL, basically you do it in two stages generally. First, you create a Hive table. You create a Hive table like this, and once the Hive table is created, you load the data the way we had been loading using Hive. Okay. So that will basically it will basically move the data to 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 a file called widgets, and then you can move that data from widgets file into your table. So this is basically a two-step process. You can do the same thing in a single step: SQL import, connect, and then directly importing the data. Okay. So this is a single step process. Here there are two steps. First you create Hive table and then you import the data. I'm just trying again if it is working now. Okay. No, it's not yet up. Okay. Now other part is that in case you want to. Okay. So in case you want to import the data from HBase to to your Hadoop, then you can also do, sorry, if you want to import the data into HBase from MySQL, then you can do it. All you have to specify is your HBase table name like this. Okay, I'll just fix these double quotes. So that's pretty much about how HBase handles it. It's still taking some time. Okay. So to you can basically import directly from your MySQL to HBase directly. The next example is how do you take out data from Hive to MySQL. In this case, what we'll do is we'll create a text file sales.log, and then we will create a Hive table for this data and then load the data into sales.log and then check whether it exists in Hive or not. So this is happening on Hive. Now, after you have done that, the next step would be to create a database table in MySQL and then use Scoop to export the data from from Hive into the MySQL one. Okay. So our it should create at the end of the process, it should create though that sales log, sales table in here. It should populate the data over here. Okay. Let me see if we can have. Okay. So I'm trying to run that again, scoop again. So stepping backwards. Right. So it has exported the data into your file. So this is the command which we have run just now. This is the one which we have run, where we have said that import the data from MySQL to HDFS. And under under Hadoop, you will see that it has created a folder with the name widgets. Okay, it has created a folder named widgets, and if you want to see that what is inside widgets, you can see that it is there, 13 September 2014, and Hadoop minus fs, Hadoop fs minus cat. So it has imported whatever we had in MySQL into this file, and the default separator is comma, not control A, as I said. Default separator in case of Hive is control A. Okay. In case of Hive it is control A, but when Scoop moves the data back and forth, it puts comma as the default separator. Okay, is that clear? So we were able to successfully import data from MySQL to HDFS. Okay, any questions on this? So here we created sample data, and in this single command we exported the data from our MySQL to this to the HDFS. Okay, so any questions still here? No? Okay, okay. So it's pretty straightforward. Now also in the same folder you will see a widget file. Okay. which is basically uh, which is basically a, a class, okay, which is basically a class like your Hibernate object relational mapping class. It is generated so that you can use it further to set data and get various data. And basically this is quite a useful thing when you are doing it in bulk every day, I mean repeatedly. Now, the next step is that let's say that we want to create a create a hive table. Okay, let's say that we want to create a hive table, and for that, actually the widgets table would be existing already. Okay, so we have said create table in the hive, meaning create hive table, and then our connection URL. And after that, we have got a table widgets. This is the name of the table as found in the JDBC, your MySQL database. So it has done the job. It has done the job. Now now you can load the data. So you remember we exported a file into HDFS here in the previous one. Okay. So you can use the same one to load that into recently. So if you see now in under Hive, so under Hive we have already we would have a table called widgets. Select star from widgets. Okay, let's just drop this table, drop table widgets. So this is what we are doing in Hive. Let's just import again. Okay, so we are just creating a simple Hive table based on the schema as mentioned by our MySQL database. So it will create a table exactly on the same lines. All right. Now, in the previous step, we had exported our data from this table into HDFS. We can use that one. I'm going back to Hive and then I'll check whether this scoop created the table or not. Let's just see, select star from widgets. Okay, so the table exists over there. And how do you say describe widgets? Right, so widget has got these tables which is lying in the Hive. This is created by Scoop for you. Now the next step is to load the data into widgets from a file in HDFS called widgets. This is what we exported in the previous step when I was demonstrating how to export data from MySQL to HDFS. Okay. Okay, so now let's see if I don't think it has done anything. Select star from widgets. Oh, it has done. Yeah, it has moved the data from this widgets file into this. Okay, and if we say describe widgets, it says this, and right. So when we say describe formatted, it gives you a lot of detail about this widgets table. And remember that we are looking in Hive right now. What the table has been, it says that this is a managed table which is being managed by your Hive. It's not an external table. Okay. And the location of the table, the actual file which will be going is here. And we have imported it. And here the field delimiter is comma, line delimiter is /n. Okay. And when you are loading it, it is loading. When we say load, it loaded based on comma separator i- from this file. Okay. So we successfully did two things just now. In the first step, we created table exactly on the schema provided by MySQL. And in the second step, we loaded the data from this file into our table. Does it make sense? So from MySQL to Hive, we have successfully done that. Sounds good to you? Now, the same thing can be done very, very seamlessly. Say we say drop table widgets. Okay, and then we go, okay, like this. We again go into, now it will do both the things together, generation of the table as well as importing the data. Let me see if we got any error. Okay, so the file which we did here in the previous to previous step already exists, and therefore it is little bit giving us trouble. So we say Hadoop fs minus rmr widgets. Okay, so we are just deleting widgets folder. Alright, now let me see if it can import everything in a single shot. This is done. This is done. Okay. What? Nothing, it is done. Okay, so Deepak is saying we have our delimiter as mentioned. You mentioned, yes, you can have that delimiter, but that's a default table created by Scoop for you. You can do alter table on that one and define your delimiter. Or what you can do is you can tell Scoop also to use a different delimiter. Okay, let's see if it has done anything or was there some error. Yeah, it has done your job. Okay, it has imported the data. So there was some error, but it recovered after trying a bit. All right. What decides the number of reducer, volume of the data? If so, what is general way of deciding it? Okay, so basically, whenever you are trying to So in this particular case, so you are asking a number of reducers in general whenever we are doing map. So whenever you do a lot of processing in reduce phase, okay, or your data is so high that your single reducer is going to get slowed down too much, then you then you generally decide on number of reducers to increase the number of reducers. And as a general thumb rule, number of free machines is should be equal to the number of reducers for you. Okay. Here for simplicity's sake, I have just taken one reducer, but can be very well done with multiple reducers. Okay. And as a thumb rule, even in the other phases, like when you do map reduce, so number of free machines for you should be equal to the number of reducers, so that you can use those machines parallelly to do the take the reduction reduce phase. Okay. So now we have been successfully able to import into HDFS as well as Hive. Basically, this is in single step. This has covered three steps. Here, first we created HDFS file, then we created a blank table, and then we loaded the data from widgets file into that table, which we created. So there are three steps. Here we have done all the three steps in a single shot. Okay. Now, now the next is that you can create a H-based table from by using scoop. Okay, let's just try to see if this can be done. Okay, so I will have to figure out. Okay, it says that we need to set column family. Of course we need to set column family. Okay, and then we say cf1. So since there is no such thing called column family in MySQL, while importing data to HBase from MySQL, you will have to mention a column family in which those columns will be considered. Now, ideally at the end of it, okay, it should be column family and say cf1. Why it keeps on changing my characters? It's doing something. Is the HBase running? I don't think so. HBase master has already stopped. None of the region servers are active. Okay. So let's just see if something works out. So we are saying that SQL as scoop import our data from MySQL into widgets at base table, and I'm hoping that it should work. Oh, there's a disk shortage. 46 GB used, 13 GB remaining. Okay. Actually, the servers I have taken right now, all of them are SSD based, which means that the the disk reads and writes are faster, and the general response is really good. The general response is really good. Is it giving error still? But when it comes to handling bigger data, it's not that good, because the disk space which is there is hardly the biggest disk space we have like 80 GB, because SSD is little costlier. So therefore, for projects, we might have to actually take up some more servers on Amazon or other places. So yeah, Gunjan's point is, have we used a cloud for infrastructure or physical machinery? No, actually, we have taken it from a company called DigitalOcean. Okay, they and we have bought some machine from basically DigitalOcean. Yeah, so it is still giving some sort of errors. The driver has not received any packet from the server. Last packet sent successfully to the server 0 milliseconds. And is it not able to connect MySQL? I think it's not able to connect MySQL. And what we need to basically do maybe that we have to, instead of specifying localhost, we'll have to say hbase shell it's only my table, dump my table. Scan my table. Right, it has not actually imported. So for some reason it's not working. Anyway, we'll actually have a look at it maybe later. Okay, so I'll have a look at it later. All right. So in a similar fashion, So HBase is one which we have not been able to try. Okay, so we'll try it maybe a later point of time and we'll debug it. Now, in the similar fashion, we have Hive to MySQL uh, import way. So first we create a file. Say we are creating this file. All right, and basically I'm trying to first move some data onto Hive. Okay, move some data onto Hive, and then say Hadoop fs minus copy from local sales log into skd. All right, now we go Hive, and then we create a table. So we have created a we have created a file in HBase. Now let's create a table in HBase, and let's say drop table sales. Okay, now we load the data from the file which we just imported. So it is not there. Okay, just a second. Okay, Hadoop fs minus ls minus ls skd. Yeah, we have to actually give a absolute path for sales log. Anyway, we have anyway imported the data already. Now as a next step we can check, yeah, we check the data is there in the sales table. So in Hive we have got a table. Oh, in Hive we have got a table which we have imported just now, or let's say delete. Okay, let it be there. So we have created a Hive table now. Now let's go on to MySQL and use scoop ex2 and create a table over here and say select star from, we say describe our sales table, right? And is there anything inside sales table? No, right? It's empty right now. Now as a first step, let's just run scoop and connect to MySQL and into sales table. Now, and we are saying this is the directory from which it has to pick up the sales folder, sales data. and this. So why is it so? Let me just describe you that. So the sales table which we have created is lying over here. You can see that describe formatted sales. Okay. So you can see that it is lying in app hive warehouse. So we can specify that to we can specify that to um, scoop, and then it can take it further. Right. So let me repeat what we did. We created a hive table which has a comma formatted, which is basically stored as a comma formatted file in HDFS. I'm sorry. So this file is basically under the hood being stored as a comma separated file, and then we are importing that file into the table. Imported that file into the table in Hive, and now we are exporting it. Now we are exporting it, okay, like this. So let's see if come in our it has come in our scoop2 database, scoop ex2. In case of the select star from sales. So the data has come from as Hive to our MySQL. Okay. So basically, you can also say that this is not really Hive to MySQL movement. It is effectively a movement from HDFS file, this file, to the MySQL. Okay. So this is how it is generally done. Okay. So you keep on copying back the data back and forth. Okay. Any questions still here? The more you will try it out, all of these commands by yourself, the more comfortable you will be. The more comfortable will you will be with with these import exports. So should I move on? Can we not copy files from HDFS to MySQL directly without Hive? So Iraya, what do you mean that none of them are giving output? So they are actually giving output, and when you say if when I ran this, it gave you the details of what is what is being done as a result, and all of them, even Scoop and everything, is actually relying on MapReduce tasks to to take the data from here to there. If you see, when we ran the import, when we ran the import, it it runs all of the it starts here when we say a scoop export, it is giving this output, right? It is showing you all the details of what is going on. Mm, Area, did you show me anything yesterday? You mean the previous earlier you had described? So that was a problem when single quote was open, right? Single quote was open and it was not closed, and that is why it was not closing. Okay, and that is why there was no output and the command was not being executed. So here Ajay's question is, can we so here when we like this, I say export directory, meaning the data is coming from this directory. Data is coming from this directory to this day, MySQL. Okay. And that is why, because that's the source of your data. This is where the data is coming from. Uh, right, Ajay? So basically, this is the source of data, and that's why we need to specify that folder. In Hive, whenever you are importing data into Hive in the managed tables, in those cases, for each table, it creates a folder containing the data. Okay. Now let's move on. No, actually, it was more of a import from HDFS to MySQL. Okay. There should be an option in Scoop, Scoop Health Export, and in that, yeah, you can actually say Hive. Okay, okay. I think you can actually say Hive table, and then it will take the data from Hive table and copy it. Okay, just to do a little bit of experimentation, and you will be able to figure it out. Okay, now I'm sorry, I've got a bad throat. Now let's talk about Apache Flume. And so just now we tried to, and we successfully did the data movement, import and export from Hadoop to a managed a structured source of data, which is MySQL. So say the other use case which lots of people face is that they have to move a lot of data from their web servers. And for that, uh, because generally in various companies where the website is little more popular, there are at least, I mean, there are multiple Apache web servers which are running continuously serving the load, and hence generating the Apache weblog for the user, generating the Apache weblogs based on the user's request. Now, as a common requirement, this log keeps on growing up. This logs keeps on growing every day. Either you drop this log, delete this, or archive the older one. I mean, delete the older one and keep only the fresh one. Or you take it to HDFS. because this data keeps on growing every day, and your normal file systems will not be able to handle it. Or the other reason for you to move all of these logs is to do a lot of analytics. Okay? To do a lot of analytics. The way Amazon does it is based on your logs of users, it gives them the recommendations, telling that you people you like this, and therefore you might also like this. And similarly, based on the logs, there are other things like newsletters are generated to the users. Those kind of things happen continuously over a cluster. So you would require your logs to be moved to HDFS cluster as soon as possible. And that is the use case being solved by Flume. Okay, that's the use case being solved by Flume. So it's basically a distributed, reliable, and available system for efficiently collecting, aggregating, and moving large log data from many different sources to a centralized data store. So similar to, there is a mechanism in Unix called syslog daemon. So all of the components log their errors to syslog-d. So on the similar lines, Flume too has its own agent to receive the log activities from all sorts of sources. Now all sorts of sources can send the log data to Flume. Okay. And okay. So, and also Flume also can put a watch on a file, that whenever a file is growing, push this data to the central system or HDFS. Okay. So the way we watch a log, whenever the way we watch a log file is, we do a tail minus f, a file name. All right. And as soon as people add the data to that file, the tail minus f pulls that data. I'll show you that. So let's say let's say there are these two terminals, and I have put a watch. I have first created a file, my log file. Okay. And I'm saying tail minus f, my log file, right? So it is not showing anything. The moment I write anything into this particular file, okay, it will appear this side. Okay. So it will keep on appearing this side as soon as I write anything into this file. So by redirection, I'm writing some data into my log file, and by using tail minus f, I'm tailing this file. Okay. Tail minus f is basically the tail without minus f will show you the last 10 lines, and tail minus f will show you the last 10 lines of a file, and will keep on showing you the data as and when it is written to the file. And this is a general mechanism of keeping a watch on a log file. So Flume can read the data from all of these sources, such as tail, syslog. Syslog is like Unix system log, and log4j. Log4j is a logging mechanism provided provided by provided for specifically for Java components. Okay. Okay. So in your Java code, similar to, so basically log4j has something called appenders, where whenever your Java code is trying to give its logs to log4j will further give it to Flume. Okay. And for that you need Flume comes up with a connector which you can mention in your log4j configuration files. So Java program will give handover. It keeps on writing to log4j, and log4j based on the configuration will keep on putting it into files, into emails, or into Flume, or into whatever it wishes. Okay, so that is how the data gets into Flume. Okay, so all of these machines, the general strategy is to put the Flume nodes on each machine running the accumulating the logs. Okay, and as and when the Flume is collecting the data, it keeps on moving that into batches into HDFS. Okay, and after a point of time, people realize that it makes sense to move the data using a peer-to-peer mechanism instead of directly moving to HDFS. And therefore, Flume came up with this mechanism where it transfers the data through a nearby node. Okay, that is something which I have not prepared a demo of, but okay. So in theory, it does a lot of movement of data from various Apache log servers. Probably we can give a bit of a demo, but it requires a bit of writing a code and then moving. So that's pretty much about Flume. Flume is specifically for moving data from servers to your HDFS. It does happen in real time, and it is actually pretty fast. It has done a lot of optimization on the transport layer on the logs, because the logs itself are huge in nature, and and moving those logs would require a very efficient transport mechanisms. Okay. By utilizing peer-to-peer transport mechanism, Flume is able to move the data from one node to the HDFS in a very fast system. Okay, so there are two kinds of delivery availabilities in which you can delivery reliabilities in which you can run Flume. First one is best effort. Okay, best effort delivery is that in case there is a node failure at any moment of time, it will not deliver. Okay, and end to end, which guarantees delivery in the node failure. So Flume generally goes with the end to end kind of a delivery reliability, in which even if there are node failures or there is a network failures from one node to the directly to HDFS, still it will be able to transport via the other nodes in the network. And that is something which is interesting with respect to Flume. Okay. But as a general thumb rule, what you need to know about Flume is that you install a Flume agent on all your web servers, and then it will keep on flowing all the logs into HDFS continuously and on real time, so that you can generate your insights, you can generate various kinds of reports using these logs. Okay. Other than using a client-side analytics such as Google Analytics, lots of insights also come from the backend one, like user clicked on this, opened this, went to this, and then submitted this data. That kind of detail is some of the details are only available in the backend, not in the front end. So therefore, churning the backend, um, churning the backend Apache logs is basically very important. My recommender, which I wrote for InMobi, was basically churning the Apache logs, which which I'm not sure we gathered via Flume, which must have been gathered by some other tool. Okay, but I did not do it myself. That movement of logs from web servers to the HDFS. There was some more people who were dedicated for that. Okay, now okay, do you want to take a break? It's 8:40. Have I put you guys to sleep today with my slow voice? Okay, okay, okay. Let's just take a quick break. So I will be back by 8:51. Hi guys, I'm back. Okay. So the next thing I wanted to discuss is Uzi. Okay. Now, in case of Uzi, Uzi is similar to your Ant. How many of you have used Ant or Makefile or Maven? Okay. Any other build tool you must have used where you define these dependencies that A depends on B, B depends on C, and so on, right? So basically, Uzi is that kind of a workflow system in which you define a lot of actions and you define which one should be executed uh, before which one. Okay, or you define in terms of what depends on what. Okay, now, so basically, the other kind of function, basically, there are two ways of. So when you execute a set of jobs or set of actions based on their dependencies, it can be triggered by people or it can be triggered based on the time, okay, frequency and data availability, and that is the Uzi coordinator. Uzi coordinator can can execute a job based on a time or frequency, or based on some data availability. Okay. And this is Uzi is very well integrated with the whole Hadoop stack. Okay. So a sample one, it looks really ugly. I can actually walk through the whole Uzi file. I'll just put it on my text file. Okay. So first let me describe you how do these things function, and then we will go into a bit of more details. So almost every every such tool forms a dependency graph. A depends on B, comma C, and D depends on E, comma F, right? And and so on. So, or you can say E, comma A, and so on. So it will create a nice graph. It will create a nice graph, and I could actually show you. So basically, you can think of it as. Actually, I'm trying to do an arrow. Okay, a better thing would be to have a. Okay, so basically, what I'm trying to say is there is somebody called A, and which is depending on say B and C. Okay, say B and C. Okay, and let's call it C, like that. And then you have got D. Okay, okay. So basically, these are various actions. B is an action, C is an action, and A is another action which requires B and C to complete first, and D is an action which requires A to finish first and then E, in this order. Okay, so the moment you execute D, it is essential that first B will execute, then C will execute, then A will execute, and then E will execute. Okay. Okay. Yeah. Gunjan, the convention I'm using it little looks inward. So arrow means A depends on B, A depends on C. Here the same arrow D depends on A and D depends on E. Okay. This is more comfortable to me, and this is how generally we draw a directed acyclic graph. So in this, so this kind of graph of dependencies, or you can even look at this way, that to where let's say when we say we, get ready for office. To get ready for office means wear shirt, then wear trousers, then wear socks, then wear shoes. Okay, you cannot wear shoes without wearing socks. Okay, so and that is the order defined. Similarly, you cannot wear trousers after you have put on the shoes, and therefore there is an order in which you do things every day. And this kind of a graph is actually complex than Uzi. If you look at the normal day life in which we do things. Okay. Similarly, you cannot wear a tie without wearing a shirt. So if you draw that graph of getting ready to office, it's actually quite complex. Okay. And you can execute. So this is the same way. This is a standard mechanism called directed acyclic graph. The only other property of directed acyclic graph is that there are no cycles. There are no cycles such as that. Had there been a path from B back to say D, so B depends back on E, then it could have been a cycle. You see the cycle? It could have been a cycle. and it would not make any sense in any sense in our circumstance. Okay. And it will be difficult to actually execute because it will take forever. D is depending on A, depending on B, and the B back depending on D, and there is a deadlock. So therefore, there should not be any kind of this cyclic dependency when we are making a directed acyclic graph. So this is a data structure called directed acyclic graph. So in case of Uzi and Makefile, even in Pig Latin, when we have Pig Latin, we we have always a dependency. When we say B equals filter A by something, so B depends on A. Okay. So whenever we want to execute B, we will have to execute A also, right? So, so almost everywhere you will see these directed acyclic graphs, and these are quite useful. And how to compute, the final way of the final way of executing things would be basically very simple. You keep on going left descending and you keep on printing in the you say that uh, pre-order. No, this is post order. Basically post order, the left node, right node, then parent node, and so on. Okay. And that, I mean, that will generate the way the whole graph is going to be printed. Right? So I'm talking about a little bit about data structures. So given a tree, how would you find out what are the order of various actions going to be for a Uzi workflow? Okay. So basically that is what we call a directed acyclic graph. It is good to know a bit more about directed acyclic graph. Okay. Because it will keep on coming back and forth again and again. Now let's have a look at the workflow in general. So you don't have to write much. You don't have to generally write these workflow of Uzi. Okay. Generally, the editor will provide you all of these details. Okay. I'll show you both the ways. First, let me go through the general structure of a basically general structure of a workflow. So so workflow is defined in XML, and every action, this is basically right now we are talking about workflow app. It has got a name. This is the name you can choose by yourself, and this schema you need to mention it exactly the way it is defined here. Okay, we are saying that this is the template or the schema of this XML is URI, Uzi, and then workflow point one. Version is point one. And we also the first the if you need to mention that what is the entry point of your graph. So if somebody says execute this workflow, which action has to be executed? There should exist an action with the same name. The way we have mentioned that our entry point is this. Okay, there has to be an action with the same name. So we define an action called name, and then we say we give it a name, and then we add bunch of actions to it. A bunch of actions defined by Uzi to you. Here we just have one one example of MapReduce. We could have one more MapReduce lined up here. Okay, and we could have more details to it. Also, in the end of every action, you can say that what to do. Okay, whether to exit or to continue. Okay, we can mention that. Now, so every action which is predefined action has got a node name, such as MapReduce in this case. Okay, and you have got job trackers URL, where is your UG server stored. Okay, you submit the job to UG server. Okay, and that is called sorry, job tracker is that task tracker. Sorry, job tracker by the MapReduce, where you have to mention the job tracker, and name node you have to mention for the MapReduce, and then the various configuration such as where is your input directory, which is your reducer, which is your mapper, and where what is your output directory. That is the standard parameters MapReduce action expects from you. Okay. Now, once that is done, you can also mention in the in workflow app definition that in case workflow app has to kill something or got killed by system, what is the what is it supposed to do? Okay, what is it supposed to do? And that's pretty much it. And this AND node is basically a sort of a end of the workflow kind of a node. All right. So this is a general structure of a OZ workflow, and visually this is what it is. Okay. Now here it should be actually here it should be kill. Okay. All right. Now so every node has got a starting point in and it has got two output. One is okay, other is error. What it needs to do, that is what we define in case of actions. Okay. So this we have defined already. And Uzi supports various actions such as MapReduce, streaming, Java, Pig. So MapReduce is to execute your MapReduce job, specifically the Java MapReduce jobs, and streaming is to execute your Python jobs. So these are all sorts of XMLs which are available, basically XML nodes which you can define in your Uzi in terms of these nodes, in terms of these actions. Okay, and this is quite useful and powerful. All you need to do is, I mean, most of it can be, most of the your job can be defined as as one of the combination of these. Okay, like sending email, executing streaming job is also powerful, where you define your MapReduce in terms of any programming, any binary or any programming language. Java is to run any program and any Java program, and then Pig will execute the Pig script. So if you have defined your logic in Pig script, then Hive is basically whatever we did just now for Hive. All those command line arguments, all those command lines arguments of Hive are available as inside the XML also. Similar is the case of Scoop, where the all those arguments are available over here also. Now you can also execute shell command. Okay, and this is very powerful, which means you can actually execute anything which you can execute from command line. Okay, now SSH you can also execute a command on a remote server. Okay, which you can do using a shell also. And there are these basic commands of Hadoop, dist cp, fs, and those kind of things. So basically, it provides you almost everything, and then it can call the other workflow from Uzi actions. Okay, so this is pretty much. Now I'll show you a bit about, you can, in case you are not able, the way we do it is generally schedule everything using using hue, using hue, okay, and job designer you go to. Under job designer, you can see you can define a action, what kind of action you want to define in this manner. So we went to workflows. Under the workflow, we have only one workflow defined yet. We can define another one, say Hadoop session 2, session 2, okay, and then we say save. Now it is defined. Okay, now we can chain up these things together and say here we are saying execute our MapReduce job. Just a second. Yeah, so now we are here. So when we say MapReduce, right, we want to add MapReduce to our folder and say our MapReduce job, our MapReduce. Now we can upload the same jar, whatever you want to upload. Okay. If you remember, we had actually uploaded a Java file earlier, right? So you can put your Java file, and you can also define various properties, and then you can use the various properties inside your definition. So this is what uh, MapReduce will look like to you. Similar is the streaming. You can define what binary is for mapper, what binary is for reducer, and what is the Java property, and you can also define a path. Okay. Now I actually wanted to show you some things. So this is just an email one, and there is a upload, edit properties, import action, schedule, copy. Okay. Actually, there is a way to see the XML file beneath there's a way to figure out. Okay, right, right. So when you execute it, you, huh, you can see in the dashboard the actual workflow that is being executed. Okay. So the way we are saying that execute a script here, say pig in case of a pig. So these are the definition of each one, and you can define those ones. Okay. And define a multiple of such actions under this one. So if you go into your dashboard and under workflows, you can actually see the details of each ones. Okay. The XML related to each of these actions. So uh, in case you have to write this XML, a best idea is to pick up from the UI, pick up these tags and copy paste. You can't really, I cannot expect you to remember everything. Okay, so all of the XML, there is a standard XML related to each one, and for under your action you can define the dependencies of these one by mentioning it here. The way we have defined that our action called word count depends on MapReduce, here we can also put pig and define it. Okay, and we can mention other parameters of it, right? So that is what the Oozie does for you. Any questions related to Oozie? Okay. So the general way of doing this, most of the tasks will be that you drag and drop and prepare your plan, or you can, or once you are done with creating uh, these your XML, you can import that particular XML into the workspace. Okay, if you have finished if you have finished creating your XML by hand, you can use import and put it here. Now Now, so this is one. So there are two ways to execute your job. First one is by going to Workflow Manager or by going to Oozie command line. Okay, not here on the server. Okay, by going to Oozie command line or by going to the interface and saying submit or saying schedule. Generally, we go for a schedule in the sense that it will keep on executing it over a period of time. Okay, and this is the job of a coordinator. Coordinator's job is to execute the data based on based on either frequency or data available. So here, if we say it's just a one time to be done, and we, right, we can say that on what data we want to define. Okay, on what data we want to run it, on based on what data should it trigger it, and inputs you need to define somewhere. So create data my ds1. Okay, and now when I'm defining my workflow, right? So now, okay, the output we can define, and then we can say save coordinator, right? So effectively, you can execute your Oozie workflow at a certain frequency. Okay, at a certain frequency. So there are only two kinds of triggers. There are only two kinds of triggers. One is your one is your data-based triggers. We define a data set and the data comes from somewhere using a URL. And and the other form of the triggers is the time-based. There are no other triggers available over here. Okay. Event-based triggers are not there right now. But what could be done is that locally on your system, wherever you're executing these, there you can define your event-based triggers, and then which can basically trigger a UZI command line executing your job. Okay. So whatever you can do from the UI, you can also do the same thing from the command line. Okay. So for coordinator, it runs a service all the time, which accepts the XML file and keeps it stored centrally and executes it. Okay. So you can go for the more details about Uzi on their manual page. That should suffice for most of your need. All right. Now let's talk about a bit about Mahat. Okay. So this session is more about giving basic details required about each tool which is frequently used. You can go into the each of the tools detail by actually trying to implement something on top of it. Okay. So Mahat, as we discussed, is basically a machine learning library, and it was written just based on Hadoop earlier, but has moved to other systems. Okay, it has moved to other systems. Uh, you know, uh, Now it even runs without Hadoop for certain algorithms. On top of, it also runs based on other mechanisms. Earlier, it was just dependent on MapReduce. Now it is no longer dependent on MapReduce. So, okay, now it is essentially a library of various functions. It is basically a library of various functions, nothing more than that. And these library functions are very, very, very important. It abstracts out the job of an engineer from a scientist. Okay, so there are people who had been working on machine learning recommendations for years. It's their PhD work, and instead of you learning nitty gritty of each one and trying to implement those, um, these Mahat provides you all that research, all that libraries in the form of a Java classes as well as in the form of binaries. Okay, so you can, even if you do not have a background on Java, then also you can use Mahat. All you need to do is format your input data in the format required by Mahat. For example, if you try to do a recommender using Mahat, it will require you to format your data into three columns separated by tab. First column will be user ID, second column will be product ID, and third column will be how much this person likes the product. So if you have to build something like a Amazon recommender, you can do you can use Mahat to do that. Okay, you can use Mahat to do that. Okay, and say your most of the code is written in Python, and you do not know much about Java, or you are just using Shell. Then also Mahat provides you these executables. Okay, we will go into the details of one Mahat program. Okay. Now, machine learning is one aspect which is has become very popular. So machine learning is basically a branch of artificial intelligence, and the computers evolve their behavior based on the data. Okay, you don't have to write code for it. You tell that this is my sample data set, and this is correct, this is wrong, this is correct, this is wrong, and you train the algorithm on this historical data to build its own understanding. Like, for example, a spam filter. So, spam filter is a standard case of machine learning. Okay, so you define that so all you need to define is you have to convert each email into a number. Okay, you have to convert each email into a array of numbers, or you can think of it as a number. Okay, so so in machine learning, you say that this is my input and this is a spam. Okay, so you gave an email and said this is a spam. You gave another email and said this is a personal mail. This is a spam. This is a personal email. This is a spam. This is a personal email. And after a while, this algorithm will automatically figure out a pattern in the input, and then will start tagging spam automatically. Okay, and that is the beauty of machine learning. You do not have to code. Okay, all you have to do is convert the email into an array of numbers, which machine learning algorithm shall be able to understand. Okay, so that is the machine learning part. It is done a lot, and when you have a lot of data, it makes a real sense to use machine learning. There are limited use cases also, because for using machine learning, you have to have at least 10,000 of data instead of hundreds of data points. Okay, at least you should have 100,000 points. Okay, before taking a step into machine learning, because most of us seems to confuse that everything can be solved with machine learning. Yes, Gunjan, unsupervised learning algorithms are also included in Mahat. Okay, so yeah, decision trees, neural network, SVM, I mean even KD networks are also available over there. Okay, now yeah, so So basically, Mahat is basically your, the cool tool to do all of this. All you need to understand is in what format each algorithm expects the input, and what format does it give the output. Okay, that's all. In case you are Java programmer, you have to form the classes and objects in that format, the dataset format, and then give it to Mahat. In case you are a Python programmer or you don't want to code at all, you can use your own utility to convert the input data, and then you can feed that to Mahat. Okay, so once you have prepared, by say you have got lot of Apache logs, you have written your pig scripts, you have written your hive queries to clean up the data, and before that you had run scoop to move the data from here to there, and once you are done with that, the next step is to run machine learning algorithm to on your formatted data. So it includes all three types of machine learning. First one is supervised learning. So you label using labeled training data to create a classifier that can predict output for unseen inputs. Okay, so this is supervised learning. So basically, on the training data, when we say label the training data, meaning there is a training data called emails. You have got millions of emails, and you have manually labeled some of the email, half of the emails, or say uh, more than half of the emails, or 90% of the emails, as labeled as spam, and rest as not spam. So you have labeled this, and now you create a classifier which basically learns on this data and then starts predicting automatically on a new email that whether that one is a spam or not a spam. Okay, so this is like a magic for lots of us, where it automatically starts learning things and taking action for you. Okay, now unsupervised learning is an interesting case. Okay, you have lot of data and you have not labeled it. Okay, and in those circumstances you can use a unsupervised learning. Now semi-supervised is that you make use of unlabeled data. Semi-supervised is something like, um, you know how should I describe, like you try to figure out from the file name, or there is this minus amount of information available, about hints available, uh, for, for unsupervised learning, so that becomes semi supervised. Okay, so as an example of machine learning, there are these general use cases. First one is recommend friends dates product to the end user. This is like everybody is doing these days. Classify contents into predefined groups. If you see Gmail has automatically classified the content into your social updates and inbox, primary, and spam automatically. So all of it is actually done using machine learning over a big data. Okay. And other use is that find similar content based on object properties. Object properties, as in, uh, you know, you figure out based on similarity indexes of various objects, and you keep on giving these recommendation to the user that there is one more product which is similar to this one. Then other use case of machine learning is figuring out what are the key topics in collection of text. So if you see news.google, it is an aggregator from Google, and there are similar other news aggregators. All they do is they go through, this tool goes through various newspapers across the world and figures out what is the key topic being discussed in that particular news item, and then correlate all the key topics together. So these are like lots of use cases in today's time of machine learning, and machine learning was not possible when you had small set of data. Machine learning shows its true colors only if you have, the more data you have, the better it gets. And therefore the whole big data and machine learning goes hand in hand all the time, because machine learning did not make much sense when we did not have too much of data, and too much of data did not appeal to a lot of organizations until we got very clean systems like recommenders or machine learning algorithms easily available. Therefore Machine learning and big data goes hand in hand but should not be confused together. There are big data problems and there are machine learning problems. Okay, it should not be, everything should not be, tagged as big data problems. And this is a general way of looking at various tools available. So if you have few lines of sample data, or you use tools like whiteboard, you go onto the whiteboard and draw it. If you have kilobytes or low megabytes data, analysis, you basically do an analysis as well as visualization using tools like MATLAB, Octave, R, and those kind of tools. And in case your data is going to megabytes or say 1 gigabyte, 2 gigabytes, then it's not possible to do visualization right away. Okay. Instead, you do the analysis first, and after analysis, you will get some output, and then you do the visualization. As data keeps on growing big, it becomes impossible to do the visualization, or you can say that visualization does not make too much of sense if the data is too much. Okay. So generally, it is the limitation of tools that I mean, when you visually represent any data, you try to avoid the big data in general. Instead, you do the analysis of big data, make it the result of analysis will be a small data which you can visually represent. So these are the general tools, and Mahat lies here when you have to churn gigabytes, terabytes, or petabytes of big data, and you want to analyze, not visualize that sort of data, then you use Mahat. Now, this is one example which we'll be taking forward. Okay, we'll be taking forward. It won't be Tanimoto. We'll use some other one. Okay, we'll use the other similarity coefficient. Okay, so just to give you a visual cue. So say there are these two guys. One is Sandeep, other is Kumar. Okay, and yeah. So there are these two guys, Sandeep and Kumar. Kumar is first name. Let's just say these are two people. Now, Sandeep likes Matrix, Sandeep likes Casablanca, while Kumar likes Matrix and Kumar likes Shawshank Redemption. And their ratings they have given on the website is this much. Now, okay, this is just for example's sake. Okay, when we talk about data, it is generally millions of records. Okay, it is just to give you an example how Mahat will produce a result. So now Mahat will figure out how much Sandeep and Kumar are similar. Okay. So total number of movies which both of them has watched would be say three, one, two, three, right? And similarity between both of them is between Kumar and Sandeep is 1. So effectively their similarity index is 1.1 by 3, which is zero point 0.3. Okay. Now let's say zero point 0.3 is a good enough similarity between these two users. So we'll say that these two users are very similar to each other, and hence let's give them recommendation. So we'll recommend Kumar to watch Casablanca, and we'll recommend Sandeep to watch Shawshank Redemption. Okay, and this is how the whole world about recommendation works. So you figured out two users are similar based on number of movies common to them and divided by total number of movies which both of them combined together have watched, and that gives you a similarity index between two users. And once you have found out very similar users, then you are able to then you will be able to give the recommendations. and this is what the output you get. So in another words, Mahout Tanimoto coefficient algorithm will expect you to give input in three columns. First one is the user ID, second one is the movie ID, and third one is a double, which is a decimal number called ratings. Okay, and the output of Mahout Tanimoto coefficient algorithm or similarity algorithm is basically person, what movie he's watching, and how much rating do you expect him to get. Okay, so I mean, it is its rating is recommended rating by Mahat, saying this guy will like this movie this much. Kumar might like Casablanca this much, and okay. So basically, the input and output format is exactly same, and to validate whether this is true or false, what we generally do is to just check the quality of this output. What we generally do is we split the input set into two halves randomly. Okay, we split it into two half. Okay, by using sample command of pig, most likely do a zero point 0.5 over there, and you get a good decent amount of output. Okay, and now you have divided the data set into two sections. Okay, now on one section you run Mahat's Tanimoto coefficient algorithm or some other recommender algorithm, and then once you get the output, you compare this output with the actual one. Okay, how much Kumar actually rated Casablanca if he watched it. Okay, and the deviation, you count all the deviation, and then you say that this is how much my recommendations are are varying are varying from the actual behavior of users. Okay, so you generally compute that the distance between the actual result and your predicted recommendation. So I said that Chintamani will, or I said that Tuhin will buy, Tuhin will like Casablanca this much. And then we looked it up and saw that, okay, Tuhin actually liked this movie this much. And therefore, my deviation is very, very less. Okay, so this deviation is what we count all the time. Okay, so when we are doing a recommendation. Now there is another terminology for recommender. For recommender we use another terminology called collaborative filtering. Okay, so Mahat's other use cases in another words given earlier are collaborative filtering, recommender, clustering, takes items in a particular class. Okay, the way we have done putting putting elements together automatically based on their general behavior or the attributes. Then classification, putting them into predefined labels. In clustering there could be any number of groups. In classification, the number of groups which form afterwards will be predefined. Okay, okay, frequent item set mining, this is another example of a recommender where you look up all the website data and figure out what three items or what two items have been sold together generally to the same person. Okay, now as an assignment of this one is import the data from MySQL to Hive and back. Okay, and as a second example, you try doing this, build an Uzi job. Okay, build an Uzi job for the voting problem. Okay, for the voting problem, you try to build a Uzi job. Okay, which should even send an email to me saying the job has finished, and put my email ID over there. Okay, and also go through the big data sets available at Amazon and come up with a problem you want to solve. Okay, and these are the public data sets available by Google. N- Right? Now, I want to continue and I want to give you an example of, okay, I want to continue and want to give you an example of Mahat. Okay, so I want to show you a hands-on exercise on Mahat. All right. Now, if you guys remember, we did a we downloaded movie lens data, but only 100K. This time we are going to do download 1 million ratings and run the ratings on top of it. Okay. Now let's have a look. So most likely, yes, yes, go ahead, Gunjan. You should ask question then and there. You should not hold it. Okay. What is PMML? Okay. Predictive model markup language. Okay. Okay. I mean, it should not be that difficult a job. Okay, it should not be that difficult a job. This is what I understand, and I think Mahat should be supporting it. Mahat should be invariably supporting it. Okay, let me see. Mahat should ideally be supporting. If they are not supporting, then okay, okay. Though I mean, Mahat is not yet. Okay. The point is to use the latest algorithms, for example, in R to model and use for scoring. Right. So see, it should not be very difficult game because the I mean the main role of most of the tools is to transform data between various of these components. Okay. And I think it should be possible to transform the data into an input which is acceptable by a particular algorithm. And the other point I want to make is that uh, there is no standard format for Mahat's algorithms other than a definition of a data set. Other than that, there is no standard format. Every algorithm has its own kind of format. Okay, so I'm not sure if defining a predefining your data format will solve anything. Right. So right now, I don't think, as I was just reading, Mahat guys are not yet supporting PMML. So you will invariably have to transform the data back and forth. Okay. You will have to invariably transform the data by yourself between say R or Mahat. Okay. Unless and until all of these component guys start accepting PMML as the standard. Okay. This is my understanding. Maybe I'll look into this a little bit more and then I will be able to provide you more thoughtful input. Okay. So, okay. Okay. So UPPI and those companies. Okay. Okay. No, if required, then we can also develop it in case they are charging too much. And I don't think it should be such a big deal to build this kind of a interface and integrate it with all of these. Okay, let me have a look. Maybe I've been looking for a new good problem in big data domain which I can develop as a product. Okay, yeah, definitely. Let's take it offline now. So first step is to download this 1 million ratings from this website. Okay, from this website, and I have already done it under Asgiri. So we have got ML 1 million here, and so if you I've downloaded that, did an unzip, and this is the folder I got. In this there are movie ratings. Let's say this is total number of movies which are there. There's an ID associated with this, and you can see that there are three aspects of it. First is ID of the movie, name of the movie, and then genre of the movie. Okay, now, and separated by two columns. And then there is a second file called ratings. Okay, ratings.dat. Ratings.dat is the the movie ID. Sorry, the user ID, then movie ID. This is second one is the movie ID. Then how much the user gave the rating, and then timestamp. This is the timestamp in millis since epoch. Okay, so these are the four columns available to you in the ratings, and then you have users. Okay, users are basically got these attribute user ID, whether male or female, and then age, and then there is one more parameter I don't know about. Okay, so these are the basic parameters, but we will stick only we require is ratings.dat. Okay, out of this we don't even require, we are not taking into consideration the rating, the time at which the ratings was posted. All right, now here what I did was quickly I used this shell script. Okay, quickly I did was I took a I did a cat. Okay, the cat means print whatever is there. So under ratings, this is what it is. Then the next step is take this output, whatever given by cat, and pass it to awk. Awk will just take first, second, third argument, will split it by columns, and then separate them by commas. Okay. Now after this, it will become like this. Okay. We got all these three columns separated by comma. Now we can save it in a file like this. Now it has basically saved our ratings into CSV while ratings.dat is also there. So rating.csv looks like this, while this is ratings.dat and this is ratings.csv. We have converted it from colon separated to comma separated. All right, makes sense to you? Now the next step which we did was we copied it from local to my folder. Okay, now it is already copied. The ratings.csv we copied from local. Okay, it is already copied there. Yeah, ratings.csv. All right. Now the next step you are supposed to do is you are supposed to execute Mahat from command line. So this time we are not executing Hadoop from command line. Instead, we are launching the Mahat from the command line. Okay, Mahat we have told in the Mahat's config we have told clearly where is our Hadoop installed. Okay, so first we define a Java home because Mahat will be executing And now here, instead of the Tanimoto coefficient, we are using similarity log lookalikehood. Okay, let's just put it here, similar one, to avoid confusion, and stick to one. Okay, similarity log lookalike. Okay, this is the algorithm. And yeah, so this is what we are going to use. We are saying that this is where our Java is stored, and we are telling Mahat that, hey, can you create recommendation based on this CSV which is there, and based on this CSV, and then whatever the output comes in, please store it in my records file. All right. And we are telling Mahad that please create recommend item based. Okay, give us item based recommendation using this particular algorithm called similarity log lookalike. In case you wanted to do Tanimoto coefficient, here you will write Tanimoto. All right. Now let's just go ahead, and this slash is just to skip the new line. Okay, we can now it is doing a basically in the Mahat user lib Mahat, there is example a jar file which contains all these details, and will be creating MapReduce programs and will execute on Hadoop. Okay, it says that this particular folder already exists, so all we have to do is we have to delete this. Okay, so it will keep on running for at least 10-15 minutes, which will might irritate you. So I like to show you that at the end of the exercise, Hadoop fs minus ls, and we say asgiri, and what I'm going to do is we are going to get is this one. What is this? Okay, it has been deleted. Let's see if it is there or not. Okay, let's just launch it first. We will delete this file. Where is it located? I require a this is fine. This is fine. Student, and then we say sysd's one, and we have got file browser. It's not there. Is it in the TMP? Yeah, here it is. So it has automatically created all of this. So I'm just going to delete each and everything. But how come I didn't see it when it did execute? Okay. Now I've deleted all of the data which was there, which was stopping it from running it. Okay, let's see if it runs now. Okay. So actually in the command line it's difficult to figure it out. Instead, in their manual, they have given it very nicely. So other recommendation algorithms are these. And also on the command line, if you say Mahat, it generally gives you the details. Okay, let me see what is going on with this. What happened to this guy? Attempt is this. Task ID attempt is. Let me see what exactly is going on with the server. So this is running still, but it was supposed to stop now. Okay, let it run, let it run. Sometimes it gives error and still running. It's doing something actually. Now it gave error. File does not exist. So it started working. This is saying the file called user student temp prepare preference matrix could only be replicated to 0 nodes. Let's just delete it once again and check what is up with the data nodes. Okay, data nodes all three are live and okay, this is fine working. Both of them are working, then why is it crying? So it runs for quite some time and then once it is successfully run, then it gives you the output. Okay. Now, basically, most of the time, this is what you're going to use. And here you'll use a different command and various arguments will change. Okay. And in case you want to change another algorithm, you can use this one. Okay. Here, this is how we are going to print the results. The results we are expecting is we gave it 3 columns and now it will give us these results. For this user ID, this is the movie recommended, which has got 5.0 as the rating. Okay, we are saying that probably in case this user is supposed to actually rate this movie, he will give 5 ratings and so on. And this is in this format, the results from Mahat will come. Okay. And these are the other algorithms. One is Pearson correlation, very popular one. Tanimoto coefficient is quite popular, and log lookalike. While cosine is recent one, which was used in a competition by Netflix, a $1 million competition. Okay, and we talked about all these four aspects. So you should go through Mahat and actually see that what are the various. Why is it saying that this could only be copied so less number of times? There are three data nodes running, and because of the data imports, the data nodes are not free. Okay, okay. The data nodes are full. Oh, that is the reason. Some of the data nodes have gone completely full, and therefore it's not able to copy the data. Okay, okay. Here, if you go, see the disk space is almost full actually. 70% all is full. And data nodes, what's the situation of data nodes? See the disk usage is full. Oh man, what is happening? Okay, I think I need to define the quotas based on users, and because some users are actually taking up all the place and others are not getting a chance. I was planning to give everyone a, a fair chance, but I think I'll put quotas. Df minus h is the command which shows you what is where, and you can use du minus csh to see what is what is being used by uh, various folders. I might have to log in as root to actually observe which node is taking up how much. So we say this and we say home and du minus csh. Okay, and du minus csh. Okay, wait. So Hadoop has taken 15 GB and rest have just taken 4 GB. Okay. Okay. So I might have to actually review almost all of these and see what is going on. Okay. And let's see, it sounds good. Du minus CSH. Okay, HDFS is something which has taken most. Oh, so because those guys have copied lot of data, that is why, that is why. So this is how the HDFS actually stores the data. This is where the HDFS is storing the data. Okay. So on a particular data node is storing the data in this folder, Hadoop HDFS data. Okay. And here the U minus CSH is taking 15 GB. All right. And what is a, okay. And if you go into current, so you can see that it keeps on giving them IDs, and under each one, this is the data. Okay. Okay. And it keeps on creating those subdirectories and bulk directories. Du minus csh star. Okay. we say finalized. Under finalized, there are these blocks. Okay. And each one has got some size, and none of them is, only one of them is 73 MB. Here, let's say subtract 353. Okay, du minus csh star. Okay, okay. So it keeps on creating these blocks under the hood as you are adding more and more data. So under the hood, this is where it is storing the data on each data nodes. Okay, by creating sub and subdirectories further and further for each blocks. Okay, now, right. So under files and folders and all that. So the files, each one is taking a small size, 148K, 148K. Good. So, so right now I'll just see if the data is required or not, and in case we need, we'll add more data nodes. So this data will automatically get rebalanced, and disk usage will come down. Okay, disk usage will come down. Okay, and that is why it's not able to, and then this Hadoop will work. Okay. Okay. So you can execute these commands in your free time, or maybe on the local machine if you have. And while in meantime I free up some space on the server or buy a couple of more machines. Actually, they are charging around $80 per month for each machine. Okay. So you'll buy, and the config is around 80 GB, 1 gigahertz, and 4 GB RAM. All right. Now, right. So this is pretty much the only thing which I could not demonstrate to you is one Mahat, how to basically this command, the last one. And as an exercise, you can try it out on your virtual machine if you have put a virtual machine. Okay. While in meantime, I take a control of the Hadoop cluster, because 3-4 teams have actually started pumping a lot of data for their project, and therefore it has been swamped, because it's their project time, right? In couple of days they will be finishing up their project, and therefore they have they want to use it up. So I'll also need to make sure that what else could be done. Maybe I'll have to move to Amazon or somewhere, because DigitalOcean is not giving big space even at a high cost. Okay. In the next session we will discuss onwards from Apache Spark. Okay. Okay, guys. Yeah. So these are the two demos which have been left, and we will also give those demos in the maybe next session if you get a time. Also, you should do it by yourself also, and you'll get a far more confidence on this Hadoop and Mahat in case you try to run a recommended example. Okay. All right. Thank you then. Have a good day. Okay. Bye bye. Yes, yes. Gunjan, let's discuss it further. Yeah. Bye, Jimmy. Bye, Gunjan. Thank you.